It's K8BYP with another entry into the topic of what is a balun and exposing the myths and falsehoods about baluns in amateur radio. And from our authorities, Brown, Sharp, Hughes, and Post, legendary authors, a real book, engineering book, Lines, Waves, and Antennas. Here's a balun under the heading of Transmission Line Matching, Not Antennas. Baluns are not for antennas. And baluns are not for dipoles to match some mythical unbalanced line to a balanced antenna, because none of my antennas have baluns and they are perfect. But the key thing here, especially with this fantasy of using baluns and end feds, is that a balun has 4 terminals. See them? 1 on the left, unbalanced, 1, 2 on the right, balanced, 3, 4. Phone, settle down. Not 3. With this end fed fantasy, what they're making is called an auto transformer. And notice in the previous image I showed you, baluns are or should be made of transmission line, not toroids. Notice what's left out of these ham know-it-all videos. Notice when, especially if you're on the air listening, my antenna has a balun. The balun burned up. That's why we don't make these toroid baluns. They're highly lossy. This balun essentially has no losses. It's made of transmission line. When we make a wound device like this is an electrical transformer. When used with dipoles, the imaginary balun has 4 leads. But see, all baluns have 4 leads. When used with a end fed, it is not a balun, it is an auto transformer. And it's attempting to excite an end fed wire by this lower leg of this transformer. Problem is, that doesn't solve anything, because the feed point is still the end of that wire, and it is still impossible to load the end of a wire. Now, on this channel and in my research, part of my work is to go back to the basics and the beginnings to see where these concepts come from. And I finally found one that's a really good expose on this idea of making a supposedly multi-band or all-band antenna like a dipole with a balun. And I want to show you the gross error with that. What they're making is not an antenna. And where this comes from is shown in this paper, broadband calculable dipole. Notice, calculable dipole is a thing, and a reference antenna is a thing. Occasionally you hear a ham mention reference antenna, implying that their antenna with their worthless balun is some kind of reference by which other antennas should be compared, and that's all false names. 1 to 3 gigahertz, very broadbanded. Now, this is not published by hams or by a RRL. Professor, Yunnan University, Korea, Center for Electromagnetic Wave Career Research. These are high-level PhDs in these topics, not hobbyists. The paper presents a design of broadband calculable dipole, reference antenna with 3 dB hybrid balun. Oh, whoa, so I can make a dipole with a balun, and it's broadbanded. No, you can't, because what you made is not a dipole and not an antenna. One dipole with a length resonant at 1.3 gig was used to cover the 1 to 3 band broadband characteristics. So I can make a broadband antenna. No, you can't. Design procedures characterized by, here's the key point that shows that something is wrong here. Dipole reference antenna, hybrid balun, hams like these buzzwords. What they ignore is characterized by power mismatch loss. And this is where this entire concept of ham dipole baluns and antennas goes down the toilet. Because what's being made here is not a functional antenna. It is a field probe, calculable standard dipoles, standard antennas, necessary to generate standard fields and measure antenna factor. Antenna factor is the ratio of the electrical field intensity of a plane wave to the voltage induced in the pickup. Here's a diagram of this system, the so-called dipole antenna on the left, which is not an antenna. Two sections of transmission line, so-called grounded at the pad end, and a hybrid coupler and a special coax line, and then a measuring instrument. Notice nowhere in this diagram is there a radio transmitter or a receiver. This balun antenna concept is only valid for field measurements. It is not a functioning antenna that can transfer or transmit power. And this system is characterized by what they're calling power mismatch loss component factors, the M sub A, B, C, D, E. Gross mismatches. Therefore, this cannot transmit any power. And there's a derivation of antenna factor with the antenna factor of square root 4a over h sub b squared RL, and then tacking on a tremendous chain of losses because this thing is so grossly mismatched it can't deliver any power. Two really interesting things pop up here. This is methods of moments analysis that shows that a thin wire antenna, which is a thing in ham radio, is defined at 0.007 wavelength. So you can apply that to your antennas and see if you have a thin wire antenna by that reasoning. And absolute scientific verification of what I have discovered myself and told you on this channel. Figure 3 shows the frequency characteristics of the resonant length, and I've shown you antennas are not resonant. But that's just a term they use to invoke electrical theory with respect to dipole radius, which means twice the dipole diameter. As shown in figure 3, the resonant length of the dipole antenna decreases as frequency increases, and I've shown you proof here of how critical the wire length is. Moreover, the resonant length was nearly invariant with respect to radius of the dipole antenna, which blows the ham theory out of the water. The antenna wire diameter is related to bandwidth. It is not. Here's where the wheels fall off the wagon and the wagon catches on fire. Frequency characteristics of the VSWR. I have a resonant dipole, which is a dipole resonant at a single frequency, but then we claim it's broadbanded. Well, that's essentially what they're doing here, but see, these are highfalutin PhDs doing it. And notice the graph, frequency of the bandwidth of this antenna from 1 to 3 gigahertz. Notice the VSWR on the left axis. If you're lucky, it's 2 to 1, and only at 1.28 gigahertz. The SWR at most any place in the response to this system is at least 10 to 1, upwards of 50 to 1, and there will be no useful power generated by this. The purpose of this, again, is only to measure the strength of the electrical field, and for a real antenna, there must be electrical and magnetic. That's where electromagnetic comes into it. But without both electrical and magnetic response, we have no power. Think of power factor. This system has no power factor. It's only electrical signal. Now, the only reasons that they go to this trouble is for making field probes for antenna testing, and these probes are horribly expensive. A low-end E-field probe is $2,000. So it pays to pack some bandwidth in these probes. In amateur radio, we tend to work on A-frequency or fairly narrow frequency bands. But there's research and testing on something called spread spectrum, which may bounce all over the place, frequency hopping. So it pays to have something that can test over a broader frequency range. But this has absolutely no validity in amateur radio. This kluge has a purpose only for antenna testing. This is not an antenna itself. So let's put an end to the myth. I've shown absolute proof here that I can make dipoles that cover the entire amateur band with essentially 1-to-1 SWR. Why can't we simply make 2 antennas for 2 bands? Or like I've done with one dipole, make it of variable length with terminals or connectors. This is real easy. But this all falls under the term antenna psychology, where people in amateur radio are making this crap up out of whole cloth. By borrowing concepts like this they don't understand and just going off and pretending with gross ignorance that somehow they've accomplished anything. And they haven't. And notice these people pushing this balun concept on YouTube, they're all saying the same thing, and none of them are on the air. So there you go. The reason they aren't on the air is because their antennas are junk. So in these times of extremely poor propagation, forget about this nonsense. Watch my antenna videos and transmission line videos, learn something, and make an antenna that really works. Did it.